Gauteng, November 2022, Grade 10 Maths Paper 1. Question 1, Part 1.1 is asking us to factorize the following. So starting with this first one, we've got 2x to the power of 6 minus 8. So the first thing I want to do when I'm factorizing is take out a common factor of 2. So I'm going to have 2. And in the brackets, for my first term, what I've got left over is x cubed. And in the second term, I've got 4. Now I look at my terms in the brackets, and I can see that I've got a perfect square in the first term, a negative sign, and a perfect square in the last term. So that means that I can do the difference of two squares. So I keep the 2 the same outside, and now I'm going to have this one bracket becoming 2 brackets. And my first term in each of the brackets is going to be the square root of the first term in the original bracket. So the square root of x to the power of 6 is x cubed for both of them. And then my second term is going to be the square root of the second term from the original bracket. So I've got the square root of 4, which is 2 for both. And then for my operations in these two brackets, I'm going to have one of them being positive and one of them being negative. And I can't factorize any further. Okay, then the next one, 1.1.2, I'm given negative x plus x minus y all cubed plus y. And so to factorize these, I know that I'm going to want to take out a common factor, and it looks like my common factor is going to be a bracket that looks like this. And indeed, I can recreate that with these terms that are on either side of this bracket just by rearranging. So I'm going to bring this y to the front, and I'm going to have negative x, and I'll put that in brackets. And then I keep this cubed bracket the same. And now I can see that I almost have what I want, right? I want these brackets to be the same so that I can take out a common factor, but they're not exactly the same. So for this first one, I've got negative x, whereas in this one, I've got a positive x. And in this one, I've got a positive y, whereas in this one, I've got a negative y. So what I'm going to do is divide this bracket by negative 1. So I'm going to take out a common negative 1 from both of these terms. And that negative is going to come out to the front of this bracket and make the positive sign here at the front negative. And then these terms are going to change signs. So I'm taking out a negative 1 from the bracket. And then on the inside, I've got the signs of each of the terms changing. So where I had a negative x, I'm now going to have a positive x. And where I had a positive y, I'm now going to have a negative y. And the second bracket stays the same. So now I can see that these two brackets are exactly the same, and I can take out a common factor. So from the first term, this one, when I take out my common factor of x minus y, the bracket x minus y, I'm left with a negative 1. And from the second one, when I take out my common factor of x minus y, I am just left with x minus y squared, because I had cubed before. And that's a positive x minus y squared. And I've taken out this common factor, x minus y. Now I'm just going to rearrange this bracket in the first bracket. And now I can see that I'm not yet done factorizing, because in this bracket here, my first term is a perfect square, my second term is a perfect square, and they're separated by a negative sign, which means that I can do the difference of two squares again. So for the difference of two squares, I'm going to have this one bracket becoming 2 brackets. And this bracket stays the same. Alright, then for the first term in each of my brackets, I'm going to have the square root of the first term in the original bracket, which is this. So the square root of x minus y all squared is just x minus y for both. And then for my second term in both brackets, I'm going to have the square root of the second term in the original bracket. So that's the square root of 1 for both. And then for one of my brackets, I'm going to have a positive sign, and for the other, I'm going to have a negative sign. And now I can't factorize any further. So for my first term, when I square x to the half, I'm going to end up with x to the power of 1. Then my second term is going to be negative 3 times x to the half times 2. So I'm going to have negative 6 x to the half. And then my last term is squaring negative 3, and that is just plus 9. Okay, then for the next part, I've got some exponents, negative exponents of x. And I know from my exponent laws that when I've got the same base, like I've got an x here and an x here, and I'm dividing them, I just subtract the exponents. So when x to the negative third is being divided by x to the negative fifth, that's the same as having x to the power of negative 3 minus negative 5. So for the first one, I'm going to have the same base, negative 3 minus negative 5. And then for the second term, I'm just going to have the negative 2 here being multiplied by the negative 1, which is positive 2, and so I'm left with x squared. Then I can simplify the first one, so I'm going to have minus 3 minus minus 5, that minus minus becomes positive, so I've got minus 3 plus 5, which is a positive 2. And this one stays the same, and now I've got like terms, so I can add them, and I'm going to have 2x squared. Then for this next question, I've got some numbers that are raised to exponents with x's in them, and I can see that I've got some different bases, but I'm going to want all my bases to look the same so that I can use my exponent laws. And the way that I can do this is by using the prime factors. So 5 is already a prime factor and 2 is already a prime factor, so I can't really simplify those anymore. So I'm going to keep the 5 one the same, and I'm going to keep the 2 one the same. But now 4 and 10, I can find some prime factors. So looking at the other bases that I've got 2 and 5 already, I know that I'm going to want the 4 to be in terms of base 2, and I want the 10 to be in base 2 and 5. So to make 4 into base 2, I'm going to, instead of writing 4, I'm going to write 2 squared. And that 2 squared is still going to be multiplied by the x exponent, and then that's all going to be raised to the power of 3. And then for the 10, I can separate my bases into 2 times 5, and this is all still raised to the same exponent, x minus 1. Okay, and now I can use some more of my exponent laws. So I know that if I've got 5 raised to the something plus the something else, that's the same as having 5 to the something multiplied by the same base 5 to that something else. So if I've got 5 to the x plus 1, then that means that I've got 5 to the x multiplied by 5 to the 1. Then for the next term, I'm also multiplying. Here I can just multiply this 3 with the 2x, because I've got the exponent 2x raised to another exponent 3. So this is going to be 2 to the 6x. And just like I had with the 5, I've got 2 raised to the power of a something minus a something else. So that means that I can write this as base 2 to the something multiplied by base 2 to the something else. So I'm going to have 2 to the 5x multiplied by the same base 2 to the negative 2. And then for these two bases, this x minus 1 is going to belong to the 2, and it's also going to belong to the 5. So I can just distribute that out. So I'm going to have 2 to the x minus 1 multiplied by 5 also to the x minus 1. And I can take this a step further at the bottom, so I'm going to keep the numerators the same for now. And again, I've got a base 2 raised to the something minus a something else, so I can separate that into 2 to the x multiplied by 2 to the minus 1. And the same with the 5, I'm going to have 5 to the x multiplied by 5 to the minus 1. Okay, and now I've got everything that only has one term in the exponent, and they've all got either base 2 or base 5, so I can just group my like terms together. And remembering that when I've got division with exponents, the ones at the top are going to stay the same sign, and the ones at the bottom are going to be a negative sign. So I'm starting with my 5s. My 5s in the numerator, I've got a 5 to the x, and I've got a 5 to the 1. And that's all the 5s in the numerator. Then looking at the bottom, I've got these two. So because they're in the denominator, this one's going to be negative, so I'm going to have negative x, and this one's going to be negative, so that's going to become positive 1. So I'm going to have multiplied by negative x and multiplied by 5 to the positive 1. And then for the 2's, I've just got 1, 2 in the numerator, so this is going to stay positive. And then I've got all of these 2's in the denominator, and all of them are going to change sign. So this is 2 to the positive 6x stays the same, that was in the numerator. And then all the denominator ones are going to be negative. So I've got negative 2 becoming positive 2. I've got x becoming negative x. And I've got negative 1 becoming positive 1. And now I can just add all the exponents with like bases together. So I'm just going to have 1 base 5. And I have x minus x is 0x. And I've got 1 plus 1. So that's positive 2 for the 5. And then for my base 2, I've got 6 minus 5x is 1x, and then minus x is 0, so I've got no x's. And then I've got 2 here plus 1, so I'm going to have 2 to the power of 3. That's my final answer, and this is going to be 200. Then for 1.2.4, I'm given these two fractions, and they both have expressions of x in the denominator. And this one's a quadratic expression of x, and this one is just a linear expression of x. And I know that if I want to subtract these two fractions, that I want to have the same denominators. So the first thing that I'm going to do is factorize this quadratic expression of x. So when I factorize this, I find that my first factor is going to be 2x plus 3, and the second one is going to be x minus 4, and my negative 11 is going to stay the same at the top. So now I can see that this, one of the factors here, this x minus 4, is almost the same as this 4 minus x. But the difference is that this is a negative x, and this one is a positive x, and this one's a negative 4, and this one is a positive 4. So what I want to do is that I can bracket this, and I can divide each of these terms by negative 1, so that the x is going to become positive and the 4 is going to become negative, and then it's going to look exactly like this factor here. But when I do that, I'm going to be changing the sign of the whole fraction, because this negative 1 is coming out, and it's going to change this sign here to be positive. So I can rewrite the second term as positive, 1 stays the same, and now the signs in the brackets have changed. So now I can see that these two have the same factor, and I want the same denominators so that I'm going to be able to add these fractions together. So this fraction here has already got the x minus 4, and the only thing that it's missing is this 2x plus 3. So I'm going to multiply the whole fraction by 2x plus 3. Well, I want to multiply the denominator by 2x plus 3, which means that I'm going to have to multiply the numerator by 2x plus 3. because 2x plus 3 over 2x plus 3 is equal to 1. So if I multiply the whole fraction by this 2x plus 3 over 2x plus 3, it's the same as multiplying it by 1, so I'm not changing the value, but what I am doing is getting the denominators to look the same. So when I multiply the second term by 2x plus 3 over 2x plus 3, I'm going to have 2x plus 3 now at the top, because 2x plus 3 times 1 is just 2x plus 3. And then in my denominator, I'm going to have the exact same denominator that I have here. So this next bit is going to be negative 11. So this one stays the same. And now I've got 2x plus 3 at the top. And 2x plus 3 and x minus 4 at the bottom. And now I can join these together because they've got the same denominator, so I can just add. So I'll have negative 11 plus 2x plus 3 over this common denominator. And I can simplify the numerator by adding negative 11 to 3, which is going to be negative 8. And the 2x stays the same. And I can see that I can factorize this 2x minus 8 because I've got a common factor 2 in both of these terms. So I can take out a common 2 here, and I will be left with x and minus 4. So I'm taking out a common 2. I'm left with x for the first term, minus 4 for the second term. And my denominator stays the same. And now I've got one term in the denominator, one term in the numerator, which means that I can cancel out these common brackets, x minus 4 and x minus 4. And so I'm just left with a 2 in the numerator and this 2x plus 3 in the denominator. Then for the final part of question 1.3, we're asked to determine the value of d if this 3x plus 2 is a factor of 6x squared plus dx minus 10. So if this is a factor, then that means that that times another bracket that looks something like that with one term in x is going to be equal to this. So I can write it like this. That's 6x squared plus dx minus 10 is equal to the bracket I was given times another bracket. Okay, so we know by FOIL that I'm going to be multiplying the first two terms together, and that's what's going to give me the x squared part of this. So I know that if I multiply the two terms together, I need to have 6x squared, and I already have 3x here. So to make it into 6x squared, I'm going to have 2x as my first term in this bracket. And then by FOIL, I also know that the last two terms, so this plus 2 that I was given and this one that I don't know yet, have to equal to negative 10. And so the only possible answer is negative 5 for this one. Okay, and then to find d, I'm going to use FOIL for the outer terms. Sorry, that's this 2. And then FOIL for the inner terms. So this product plus this product is going to give me the value of d. So I know that d of x is going to be equal to the outer ones, that's 3x times negative 5, plus the inner ones, which is 2 times 2x. And I can simplify these. So this is going to be negative 15x plus 4x is equal to negative 11x. So if dx is equal to negative 11x, then that must mean that d is equal to negative 11. Question 2, the first part, 2.1, is asking us to solve for x. So for 2.2.1, I'm given these two brackets, 3x minus 1 and x plus 2, and I'm told that they're equal to 0. So the product of these two things is going to be equal to 0, which means that either this one is equal to 0 or this one is equal to 0, because anything times 0 is going to be 0. So I have that either 3x minus 1 equals 0, or x plus 2 equals 0. And now I'm just going to solve for x. So for this one, I'm going to take 1 over to the other side. It's going to become a positive 1. Then I'm left with 3x on this side. And then I'm going to divide by 3 to get x on its own. So I'm going to have x left over on this side. And then the positive 1 that I brought over here is going to be divided by 3. And that's just going to be 1 over 3. And then for this one, I'm just going to take this positive 2 over to the other side, and it's going to become a negative 2. And I'm only left with x on this side. So I have that x equals negative 2, or x equals negative 2. Okay, and if you're not sure, you can check. You can put 1.3 back into x's place here, and you will find that this bracket is going to be equal to 0. And so whatever x is going to be, and whatever the answer of this bracket is going to be, when it's multiplied by this 0, 1, the answer is going to be 0. And same thing, when I put x back, and when I put negative 2 back here, this bracket is going to be 0. And so whatever the answer is of this bracket when I put x in, it's going to be multiplied by the 0, 1, and then everything is just going to be equal to 0. Okay, then moving on, still solving for x. So now I've got some numbers with x in the exponent. So the first thing I'm going to do is remember my exponent laws. So this 3x is going to stay the same, and minus 2. And then if I've got 3 raised to the something minus the something else, it's going to be base 3 to the one thing, and then base 3 to the something else, multiplied by base 3 to the something else. So I'm going to have this, and that's still equal to 3. And now I can see that I've got two terms. They're separated by this minus here. And so from the first term, I can take out a common factor of 3 to the power of x. And from the second term, I can take out a common factor of 3 to the power of x. So I'm going to take out 3 to the power of x. In the first term, I'm just left with 1. In the second term, I'm left with 2 times 3 to the minus 1. And that is equal to 3. And I can simplify what's in the bracket. So this is 1 minus 2. And when I've got something raised to a negative exponent, it just moves to the denominator. So I'm going to have 2 over 3 is equal to 3. And so 3x is equal to 1 minus 2/3 is 1/3. And then divided by 3 is going to be 9. And then I can just write 9 as 3 to the power of 2. So I see that 3 to the power of x is equal to 3 to the power of 2. And so x is equal to 2. Okay, then this next part, 2.2, I'm given this inequality here, and I'm asked to solve for x. So the thing to remember with an inequality, if I've got two inequalities happening at once, anything that I do in the middle is going to be replicated on this side and on this side. So I see that my x is here in the middle, and but it's in this fraction, and there's this 1 minus. So I want to get rid of everything else except for x. I want to get x alone in this middle part. And so whatever I do to the middle part to get x by itself, I have to do to the left-hand side and to the right-hand side. So the first thing that I can do here is subtract 1. So I'm going to minus 1 from the middle, which means that I'm minusing 1 from the left-hand side and I'm minusing 1 from the right-hand side. So on the left-hand side, I'm going to have minus 1, which is minus 2. And then in the middle, I have 1 minus 1, which is going to be 0. So I'm just left with this fraction. And then on the right-hand side, I do the same thing. 5 minus 1 is going to be 4. Then I'm going to multiply everything by 3. So I'm multiplying the middle bit by 3, and I'm just left with this negative 2x. Then the left-hand side must be multiplied by 3 as well. That's going to be negative 6. And the right-hand side must be multiplied by negative 3. So that's going to be, by positive 3, and that's going to be 12. So this is going to be negative 6. I'm just left with 2x. And this one is 12. And now I want to get x on its own, so I can divide the middle bit by minus 2, which means I'm dividing this side by minus 2, and I'm dividing this side by minus 2. So minus 6 divided by minus 2 is 3, and in the middle I'm just going to be left with x. And then on the right hand side I've got 12 divided by minus 2, which is minus 6. But now what I have to remember is that when I've got inequalities like these, and I divide or I multiply the whole inequality by a negative number, that means that my equalities have to change direction. So here where I had the less than and equal to, I must have the greater than and equal to, and here where I had the less than, I must have a greater than. So my inequality is going to look like this, and I can rewrite this starting with the negative 6, that's the smallest number. So I'm going to have negative 6 is less than x, which is less than or equal to 3. Okay, and then the next part asks me to give the number of integers that will satisfy the inequality. So the integers that are going to satisfy the inequalities are the ones that lie in this interval, this negative 6, not including negative 6, and up to 3. But now I am including 3 because I've got an equal to here and I don't have an equal to here. So I'm going to start with the integers above negative 6. So the first one is going to be negative 7, then negative 5, then negative 4, up until 0. And then I've got 1, 2, and 3 is going to be included. And I can just count those up. And the number of integers is going to be 9. So again, that's because x is equal to not negative 6, but it can be negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, and including 3. And if you count all of those are 9 numbers. Then for the final part of question 2, 2.3, we've got two equations in x and y that we've been asked to solve simultaneously. So I'm going to call this equation 1, and this one is going to be equation 2. So the first thing that I notice is that equation 2 has got the variables in fraction form, and I don't really want that. It's going to be difficult to work with, so I'm first going to simplify this equation 2. Okay, by cross multiplying. So I'm going to multiply the 5 by both of these denominators, the 2 and the 5, so it's going to be 5 times 10, which is 50. Then the x is going to be multiplied by 2 to be 2x, and the y is going to be multiplied by 5, and it's going to be 5y. So my new equation 2 looks like this. And I'm just going to rewrite equation 1. In fact, I'm going to rearrange it to look similar. So this is negative y and positive x is equal to 4. Okay, and then to solve the system of equations, I'm going to want to get one of the variables in terms of the other variables. So I'm either going to have an x equals a something with y in it, or I'm going to have a y equals a something with x in it. So I'm going to choose equation 1 because the coefficients of y and x are just positive 1 and negative 1, which makes it easier for me to work with. And I'm going to choose to write x in terms of equation y because I can just take y over to the other side, and my x is going to be positive and my y is going to be positive. So I'm going to rearrange equation 1 to look like this. X is equal to 4 plus y. And now that I've got an expression for x in terms of y, I can substitute this into the other equation, equation 2. So everywhere that I see an x, instead of writing x, I'm going to write 4 plus y. And I always tell the examiner what I'm doing, so I'm going to say sub x equals 4 plus y into equation 2. So the first term is going to stay the same. This is 5y and then plus 2. And instead of x, I'm going to say 4 plus y is equal to 50. And now I'm just going to distribute the 2. So I'm going to have 8 for the first one and plus 2y for the second is equal to 50. Then I'm going to keep all my y's on one side and I'm going to take all my numbers to another side. So on the left-hand side, I've got 5y plus 2y, which is 7y. And then on this other side, I'm going to have 50 minus 8, which is 42. And so I can solve for y, and I get that y is equal to 6. And then I can take this y equals 6, and I can substitute it either back into equation 1 or into equation 2, whichever I like. Again, I'm going to choose equation 1 because it's simpler. So instead of everywhere that I see y, I'm just going to write 6. So for equation 1, I have a negative and then y, so I'm going to write 6 plus x is equal to 4. And I'm going to take the 6 to the other side, it becomes positive, and I'm going to have 4 plus 6 is equal to 10. Okay, and I could also have subbed this y equals 6 into equation 2, and I'm going to get the same answer for x. So now if I'm in equation 2, everywhere that I see y, I'm not going to write y, I'm going to write 6. So I've got 5y, I'm going to replace that with 6. 2x is equal to 50. And I'm going to keep my 2x on the left-hand side, and I'm going to take 5 times 6, which is 30, over to the other side. 50 minus 30 is going to be 20, and x is equal to 10, just like we had before. So you can do either one, sub y into equation 1, sub y equals 6 into equation 1, or you can sub y equals 6 into equation 2, and you will get the same answer for x.